If the surfaces of an object lie in either a horizontal or vertical position, they appear in their true shape in one of the three views and as a line in the other two views. On this print, the 4.5-inch by 3-inch surface is seen in its true view, its true shape. However, when you rotate the view into its front view, this surface can only be seen as a line. When a surface is sloped or inclined in only one direction, it is not seen in its true shape in the top, front, or side view. It is seen in two views as a distorted surface, and on the third surface it appears as a line. In this example, the pictorial view clearly shows two surfaces as angled or inclined. When creating the three main views, these inclined surfaces cannot be described accurately. Therefore, trying to manufacture this part without clearer information would not be possible. When an inclined or angled surface must be described on a print for manufacture, an auxiliary view must be used. An auxiliary view is essentially a view created from the other views that specifically describes the inclined surface. The view is created like the three main views in the sense that it is drawn as though the viewer is looking at the inclined surface straight on. Notice in this example that the sloped surface is not clear in the top or right side view. Only the front view shows the true length of the sloped surface. The right side view doesn't even indicate that a sloped surface is present. To create an auxiliary view, use the view that describes the true length of the surface. The auxiliary view will be drawn parallel to the line of true length. Make sure to leave enough room to draw the auxiliary view, and if space is limited, the auxiliary view may be drawn elsewhere on the print. We will demonstrate the thinking that is required to create the auxiliary view. Start by drawing a line parallel to the inclined surface in the front view. Next, draw the width of the inclined surface for the auxiliary view from the information in the right side or top view. This line is drawn parallel to the view. Next, we must rotate this line so that it can be drawn perpendicular to the first line in the auxiliary view. Next, draw the line in its proper position. Duplicate this line now in position on the auxiliary view. And finally, draw the last side parallel to the first line that was drawn. Even with this very simple example, we can see the importance of explaining an inclined surface by means of an auxiliary view. The final drawing of the inclined surface looks completely different from the information provided in the three main views. We have essentially taken this line and this line to accurately describe what the angled surface actually looks like. Obviously, there are far more complex surfaces that must be explained by means of auxiliary views. However, if the rules that have been demonstrated here are followed, auxiliary views can be used consistently and reliably to provide the necessary information to create part features. Section views are used when internal features on a print must be described clearly. Section views are drawn as though the part has been cut along a plane and the viewer is now looking straight on at the cut surface. This part, of course, does not actually get cut, but we imagine that it is cut, exposing what is on the inside of the part. We then draw what the part would look like on the inside. The large diameter and the small diameter holes we would now see, but they are now drawn as object lines, no longer drawn as hidden lines since they are not hidden. It must be crystal clear that this new view is in fact a section view. So, section lines are drawn on the surface that we imagine being cut. This indicates to the viewer that this surface is solid material. Section views are only used when necessary. If at all possible, a section view is used in place of one of the three main views. The cutting plane line is drawn to show where the imaginary cut takes place. The ends of the cutting plane line are drawn perpendicular to the cutting plane line and terminate in arrowheads. The arrowheads indicate the direction that the section view is viewed from. Think of it like this. Anything on the back side of the arrowheads is cut away and disposed of. Now you look at the cut surface of the piece you have left. This surface is seen in the front view. The arrowheads of the cutting plane line point your eyes in the direction telling you to look at this surface. This is now what you will see.